Hi and welcome back to another video. In this session we're going to be finding the position of the neutral axis for this composite beam. Automatically we can see that we've got a wider flange at the bottom than the top. So that means the position of the neutral axis for a symmetrical beam, which is in the middle of the beam, is going to be different in this scenario. As we've got a greater mass at the bottom, that position of the neutral axis is going to be slightly lower to the base of this beam. But how do we find out the position? Well, we have this formula here which says the position of the neutral axis, which is given by this y with a line at the top, is equal to the summation of area of each increment multiplied by the distance of the segment neutral axis from the base divided by the area of each segment. Now, this sounds a little bit confusing, but what does each bit mean? Taking this composite beam, what do we need to do? We need to split this into 3 areas using rectangles. So can you see how this becomes one area at the top, this flange? The web becomes one rectangle, and lastly we have the bottom flange. So I've drawn the equivalent beam split by these 3 rectangles down below here. What do we say? We give each part a label. So I'm going to say this is label A, that rectangle, this is going to be B, and then this final flange is going to be C. Now the equation says for each part, so that's going to be A of A, B, C, we're going to multiply it by Y. Now Y is the distance of the segment neutral axis from the base. So what does that mean? So here's the base. The base is down here at the bottom. That's going to be our position 0, so 0 millimeters. We look at each segment and we define the neutral axis. So the neutral axis of the segment for a symmetrical shape is always in the middle. So that's going to be in the middle of the top flange. Now we've got this long rectangle. The neutral axis for that specific rectangle is going to be in the middle, and likewise for this bottom flange it's going to be in the middle. Why? Because all of these parts are symmetrical. So what I've done is just drawn it with a different colour. So looking at each rectangle, we're going to define the y of A, the y of B, the y of C. So remember, we said we're going to define from the base, which is 0 millimeters. So that means from 0 to the top or the neutral axis of this segment, this bottom flange, what is it? This distance. So that's, well, we know the thickness is 20 mil, so that becomes halfway through, which is 20 divided by 10, so that is 10 millimeters, and that's going to be y of C. Then we look at this distance from the bottom of the base to the center point of this middle rectangle. So what is it? We've got 450 mil, so in the middle that's going to be 225, and then we also have to include the thickness of the flange, so that's going to be 225 plus 20 mil. So that's going to be 225 plus 20 mil, which is 245 millimeters from the base. And now finally the last one, which is from the base right to the top. So what is that? That's going to be 20, which is the bottom flange, plus 450 plus half of this rectangle, which is 10. So that's going to be 20 plus 450 plus 20 over 2, which is 10. So that's going to be 480. So let's start plugging in the formula. The summation of AI yi all over summation of AI, and that's going to equal A1 or AYA plus AB YB plus AC YC all over AA plus AB plus AC. So if we say A1 Y1, which is the area of A1, which is 20 times 200, so that's going to be 20 times 200, all multiply by YA, and YA we know is to be 480. So that's going to be 480. And then we've got A2, sorry, that's AA, AB, YB. That's going to equal the area, which is 10, multiplied by 450, all multiplied by 245. And then lastly, we've got AC, YC, which is equal to 200 multiplied by 400 as the area, all multiplied by the thickness, well, the neutral axis YC, which is 10. So what do these equal? So we've got 192,000 millimeters cubed. We've got 110,2500 millimeters cubed, and then lastly we've got 80,000 millimeter cubed. So if we add all of these up, that equals, well, the summation equals 310,250 millimeters cubed. Then lastly, all we have to do is find out the summation of AA, AB, AC. So that's going to be a summation of AI is equal to all the areas, so this first column here, which is going to be 200 times 20 plus 450 times 10 plus 400 times 20. So that's 16,500 millimeters squared, and therefore we can say the position of the neutral axis y bar is equal to 310,2500 all divided by 16,500. So that's millimeter cubed over millimeters squared, should just give us millimeters, and that's going to be equal 188 millimeters from the base. So our y bar here, here's our neutral axis, and that is equal to 188. So hopefully you've understood. If you've enjoyed the video, please do give it a like, that really helped me out, and please do subscribe.